Alright guys, so here's the max flow algorithm. I apologize in advance for the crappy audio quality, but I really need to get a better microphone and have yet to do so. So here's the max flow algorithm. Basically you've got a source and you've got a sink. You have S stands for source and sink is T for whatever reason. Basically you're measuring it as if you're looking as if there's pipes. And there's pipes that are flowing water, and you're trying to figure out how much water can I send from S to T before I can't possibly fit any more water, before it'll start like backflowing and going, instead of going from here to here, it'll start going from here to here because I'm giving it too much water. So that's the basic premise of the algorithm, and let's get right to it. So if we scroll over here, I have a graph set up. And this graph is going to give us sort of our base point. The idea here is that we're going to look at the tallest amount, or the largest amount of units or flow that can go through. So starting at S, we look at S and we note that we can send 7 through. Can 7 get all the way to T? Well, we know 7 can go to A can go to D, and it turns out, well, 7's less than 10, so yes, we definitely could send 7 all the way through to T. Could we send 5 through? Okay, so 5, and 5 is less than 10, so yeah, 5 could go through. Now let's look at S. Well, S can go through at 10. 10 from S to B, 10 from B to D, and then 10 from D to T. So we know 10 is the largest amount we can send through out of those three. So let's pick 10. And then we write down the path, S, B, D, and T. So this is the first part of our max flow. This is sort of the first flow. Now what we're going to do is we're going to reverse the graph on every single arrow that we've touched and make it go backwards. And then we're going to fix the 10 as well. Well, actually, we'll get into that later. But basically, we're going to flip the arrows. So I've actually already done that down here. So now the arrow that was going from S to B, sorry about that, from S to B, now goes from B to S. And same for all of these along this path. So now, here's the important new concept. Because with this new graph that we're looking at, we can now go places that we never could go before. For instance, let's try putting 7 through. If we take 7 normally and put it through, the issue is we can go S to A to D, and we try and go from D to T, but we can't because it's already being used. The arrow's already been flipped backwards. So, unfortunately, we can't go that way, but now we can go a new direction. We can now go S to A to D, D to B, B to C, and C to T. So that means 7 is the max flow that we can put through here. A lot of people would have just said, well, we could put 5 through and 5 would go through, and you're right, but that is not the next max flow. So 7 is the next. So 7, and then we've got, oh wow, that's really fat. Okay, so we've got 7, and the path is S, A, D, B, C, and T. Now, unfortunately, after doing that, if we flip the arrows, we can quickly see we won't be able to get anywhere else. So an important note is you only flip the arrows that haven't been flipped yet. You don't like flip these ones that you've already flipped and make them flip the other way again. You just leave them facing the sink. So the max flow is just going to be the simple addition of this number plus that number. So max flow in this case is 17. Pretty simple, pretty straightforward, and for the first part of the problem, that makes sense. Alright, so let's go on to the next example we have down here. The next example is this graph right here. So again, we start and we look and see what is the max flow we can go through. Well, we know we can pick between either 8 or 7. Now we don't know we can actually send 8 through all the way, because there might not be a path allowing us to send 8, but we know the max we can start with is 8 or 7. So let's look at 7 real quick and see, can we send 7 through? S to C, C to E. Well, actually, just directly we can go S to C, yeah, C to E, E to F, F to C, or F to D, and D to T. But we can go farther than that if we want, or better than that, because we can do 8. We can send 8 from S to A to, let's go B, B to T, and then we're done. So if we do that, we've got 8, and the path is S, A, B, and T. So that's the first bit. Now give me a quick second and let me flip the graph, and we can work on the next part. Bear with me for just a quick moment. Alright, so now I've flipped the graph, and we have this small detail that I need to point out. And it's that thing that I was talking about in the algorithm that I'd explain later. And it's where here we sent through a max value of 8 going from S to A and A to B. However, 10 is less than 8. And so what we do is we take 10 and we minus 8 from it, which leaves us with 2 still going in this direction. But we'd have 8 going in the opposite direction. So you'll note when I updated the graph, I updated it like that. I put 8 going this way and 2 going from A to B. So hopefully that makes sense. It's just a little detail. If we wanted to, if we could somehow send, like let's say there was another thing connected right here, and this was a 2, we could send S to C, C to A, and then A to B, because we could still do a maximum value of 2. So like I said, that's just a quick detail. In this example, however, we don't need to actually use that, because what we can do is we can see that we can use S to C, and we can send 7. We can send S to C, C to E, and then we can go from E to F, and then from F back to D, and then from D we can go to T. So we have 7 as the max flow, and it's C, or S, C, E, F, D, T. So the max flow is going to be the maximum you can push through, and as it turns out there are only 2 children, so we know there's only going to be a max flow of 2 units. So the units are 8 and 7, so 8 plus 7 is 15, so 15 is the max flow in this problem. Hope that made sense. I'll do one more complicated example in the next video. Hope you guys liked it, and hope that you are learning this. It's a pretty simple algorithm, pretty straightforward, so hope it makes sense. Thanks. Bye.